Okay, going back to number 7. I think, but when I stopped the last one, we had settled on this was an ellipse because of the plus sign and the different coefficients. And the x and y are both squared. And so I may name the foci, but you're not responsible for that. Right now I can't really see anything about the center or the vertices, but I do know it is an ellipse. All right, so in order to get it in the right form, out of standard or general form, I'm going to group my x's, I'm going to group my y's, and I'm going to move the 39 over, the constant over. Then I'm going to, it's logical, I'm going to factor out the 7 and the 3. And I've left some space to add something in which case I'll need to add it to both sides. Half of 6 is 3 squared is 9, so I add 63 since I added it to this side. Half of 2 is 1 squared is 1, so I'm going to add a 3 to this side. So I have 7 times. This is x minus 3 squared, 3 times, this is y plus 1 times y plus 1, and 39 and 63 and 63 is 105. So then I want it equal to 1, so I'm going to divide by 105. 7 goes into 105. I think 15 times. Yeah. 3 goes into 105. 35 times. And so that's equal to 1. All right, now let's see. So this is what I'm looking at right down here. My center is, look at what it's paired with x right here. So my center is 3, negative 1. And now I'm going to go and graph my center. I always go to my center and then start moving around. 3, negative 1. And then underneath the x coordinate, so I'm going to go across square root of 15, which I think I have on my calculator here, square root of 15. Oh, I don't. All right, so square root of 15, and I'm also going to need the square root of 35. All right, so I'm going to go out square root of 15, which is 3.8, and up and down square root of 35, which is almost 6. So this one I'm going to go out 1, 2, 3, almost 4, and back 1, 2, 3, almost 4. And then I'm going to go up and down square root of 35, which is almost 6. 1, 2, 3, 4, 5, almost 6. 1, 2, 3, 4, 5, almost 6. It's an ellipse, so I join them together like this. Okay. And so since it's long this way, these would be my major vertices right here. And so I'm thinking to myself, how did I get to those major vertices? I would say that I counted up and down for the longer ones instead of the shorter ones. These are minor vertices. I'm going to name my major vertices. So I was at 3, negative 1. And what changed is I went from negative 1 up, square root of 35. Let's get some more room. Okay, so my vertices are negative 3, positive 3, and I went negative 1 plus square root of 35, and then I went back to 3, negative 1, and I went down square root of 35, or you could give a decimal. The foci you wouldn't be responsible for naming next year in calculus, but if I wanted to, I would take, if I needed to for some other course. This is all we would need to know for calculus. The center and the shape. But if I subtracted these to get my foci to land inside here on my major axis somewhere, they'd be in here somewhere, I would subtract these two numbers. 35 minus 15 is 20. And then I square root that, and I would move up from here square root of 20 and down square root of 20. And you can see that on the answer sheet. I think there's a correction on the answer sheet. Whoever filled this out, this is not my worksheet. I found it somewhere. I thought it was really good. But on the foci, they accidentally put -3, not +3, but it's a +3. Okay, so now number 8. What is this? Only one item is squared, so it's a parabola. This one is actually going to go sideways since the y is squared, and so I'm going to solve for x. So I'm moving everything over. X is -4y squared plus 32y minus 68. One thing you could do if you want to is you could leave the 68 over here with the x and just move all your y's over, or you could just scoot it out like this. Group your y's and just leave the 68 hanging off the end. And I'm going to be adding something in to complete the square, and so I'll need to balance that. I'm going to factor out a -4, gives me y squared minus 8y. So far I haven't really changed anything. I've just rearranged this given information. Half of 8 is 4 squared is 16, but this is actually a -64. So to balance that, I could put a -64 on this side, or I could just add 64 here to balance the -64 that I put right here. Because I introduced a -64, so I can get rid of it on the same side with a +64. So I want to have solve for x, and I have -4. This is y minus 4 times y minus 4, or y minus 4 squared, and this is -4. Follow your variable. Why I keep saying that, for my vertex, this is a y value paired with y. That goes in the back. So that's actually your k, and this is your h. Follow your variable. You'll do it all next year in calculus. This is paired with y right here. All right, so I'm going to then go to my vertex, -4, 4. And this one is going to be going sideways. It'll go to the left and be very stretched because it's negative. We're not going to go over how to find the focus in Directrix, but you could find another point by maybe filling in -5. Let's fill in, I don't want to fill in for x. I want to fill in for y. So for y, let's say if I filled in 3 for y, because I'm looking to see what's happening right here. This one has a very severe stretch because of the 4. But, so I may not get a point on my graph, but let's see. X is equal to -4, y minus 4 squared minus 4. I'm going to put in 3 for y, and so I get x. My x coordinate is -1 squared minus 4, so I get x is -8. And so that wasn't bad. I have another point at x is -8 when I put in 3 for y. And so it's right here. It's going this direction, counting on my symmetry. And so that's that one. Let's go to number 9. Find an equation of a circle. All right, so our circle is going to be x minus h squared, y minus k squared equals r squared. All right, x minus -6, y minus 12. And now we're at -6, 12. Get some more room. So I'm always drawing a picture so I can think. I'm at -6, 12, right here. And we know the line's tangent to y equals -2. So my circle's coming in center. It's coming in like this. It's tangent to that line and goes away. So I know my radius is 12 and then a little bit more to -2. And so it's 14 in all. So this radius is 14 units long right here. 12 and then 2 more. And so my equation is x plus 6 squared plus y minus 12 squared equals 196. Let's see. Okay, now the next one. Okay, let's see what this is. Classify the conic section and find the center. All right, parabola, circle, ellipse, hyperbola. All right, it's not a parabola because there's 2 squares. It's not a hyperbola because there's a plus sign. It's a circle or an ellipse. I picked circle. It's a circle because the coefficients are the same. But it's not in the right form, so I'm going to group my x's. I'm going to group my y's. and move this constant over, negative 17 over. All right, now I'm going to factor out a 2. This one's going to get kind of messy, but that's okay. I'm factoring out a 2 out of 2 and 14, and the negative 17 still over here. Half of 1 squared is 1/4, but that's really adding 2 times 1/4, or 1/2 to this side. Half of 7 squared is 49/4, but it's really 49 halves to that side. So this is 2 times x plus 1/2 squared. How did I know that? Because I had 1/2 times 1/2 gave me 1/4, and 1/2 plus 1/2 gives me 1. This one is 2 times y. I squared 7 halves, so it's 7 halves squared. This right here is 50 halves, which is 25. Minus this 17. 25 minus 17 gives me 8. And the form for a circle is x minus h squared plus y minus k squared equals r squared. So I don't want these 2's here, so I'm going to divide everything by 2, because you don't want coefficients in front of here. So I'm dividing everything by 2. So I'm working with x plus 1/2 squared, y plus 7/2 squared equals 4. So my center is negative 1/2, negative 7 halves, negative 1/2, negative 7 halves. And I'm going to radiate out the square root of 4, which is 2, from this little 1/2 mark. 1, 2, 1, 2. And then I'm going to go up 2 and down 2 to where I'm in the halves from the 1/2 and the negative 7 halves. And once again, you could think there must be some way to also write this in polar coordinates, but I had to teach you conic sections before I went any further. All right, number 11. Number 11, parabola, ellipse, circle, or hyperbola. Not a parabola, 2 things squared. If I rearrange it, I have 4y squared minus 9x squared minus 18x plus 16y minus 29 equals 0. Since this one's negative, it's a hyperbola. We might talk about the focus and the vertices and the asymptotes, but the main thing I want you to be able to name is the center and draw it. Got to be really, 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 really careful with your minus sign here. All right, so I'm going to group my y's. 4y squared plus 16y. You want your positive one to be first. Be really careful here. I'm going to group my x's. I'm going to factor out a negative, so that gives me 9x squared plus 18x. Be really careful with your negative. I'm going to move my 29 over. Take out a 4. That gives me y squared plus 4y. Logically, I would take out a 9, x squared plus 2x. And now I'm ready to complete the square. Half of 4 is 2 squared is 4, but I've really added in a 16. Half of 2 is 1 squared is 1, but I really put in a negative 9. And so I'm going to say minus 9. So this equation becomes, I'll write it down here, 4 times y plus 2 squared minus 9 times x plus 1 squared equals, this ends up being 36. I want it equal to 1, so I'm going to divide everything by 36. And that gives me y plus 2 squared over 9 minus x plus 1 squared over 4 equals 1. Now be really careful with your center. Follow your variable. This is y plus 2 and x plus 1. So my center is negative 1, 2, because you're looking at your variable, what it's paired with. So my center's negative 1, negative 2. Now I'm going to count, this is a 9, so I'm going to count 3. But I'm going to count up and down 3 because it's underneath the y coordinate. So I'm going to go up 1, 2, 3, and down 1, 2, 3. Under the X is a 4. X's go across. So from my center, I'm going to go across 2 and back 2. Once again, some people teach all of these formulas and A's and B's and K's and H's and P's and Q's to keep straight. But you can keep it straight from finding your center and following your variable. If it was an ellipse, I'd be through and just draw my ellipse. But it's a hyperbola, so we're going to do this funny box. I'm going to go through the corners of the box. And then I've got to decide, am I going to do it from these or from these? How you decide is what comes first is a Y. Can't read it much anymore, but Y was first. So I go up these spaces that I went up 3, right on this vertex, and follow my asymptotes off. And that's my hyperbola. Your foci, if you found them, you would add 9 and 4 together and go back to your center. You would count from your center. You would count up square root of 13 and down square root of 13. And you can find that if you want to look at it on the solution page. Let's name our vertices anyway, even though I crossed them out. But if you found them, you ought to be able to name them. These are my vertices here, and I really think one of the, oh no, they got these right. You can see this dot is -1, 1, and this dot is -1, -5, because from -2 you went up and down 3. All right, so now let's go to 12. So we're going to write equation for this hyperbola. So I'm going to say, first of all, it's gone up and down, so it's a y minus something squared minus x minus something squared equals 1. Now I know I counted, my center was -1, -2. Make sure you put the correct variable with the right thing. This is y minus -2, and this is an x minus -1. Now I don't know what numbers to put, but I counted up 1, 2, 3, and so this should be a 9 because I went up and down. 1, 2, 3. How far did I go across? We can tell from this box I went across 1, 2, 3. So they both happen to have a 9 on the bottom. Okay, now let's go to 13. 13, I wouldn't give you 13 because it involves the foci, which if you're ever having to really design one, you could find the foci. You can figure it all out from that. Number 14, I'm going to let you do yourself. You might want to draw a picture and think about it, but there's a way to find the center and the radius from this information and write the equation of the circle. And then you can check your answer at the bottom. Let's see if we're going to do 15. Write an equation for an ellipse. You could do it like this. It's an ellipse. X minus -9 squared plus y minus -5 squared equals 1. That's filling in my center. All right, so you're at -9, -5. And you know you have a vertex at -9, -16. So they're counting down this way from -5 to -16. They counted down, up and down. There'd be another one up here. They went down 11 points. Up and down would be like under the y. So it went down 11, which means it's also got to go up 11. So I put 121 here. Now, on your foci help you find out this number right here, which we're not going to get into. You would have more information about how far to count across, but you'd be able to figure that out by, you would know that like this number minus this missing number, we'll call it a squared, should end up being -5 plus 6 root 2 squared. and that would help you find this number right here. And I guess I've gone that far. We could actually find that. Let's do it. So we could do it by hand or with the calculator. So I had parentheses -5 plus 6 square root of 2 squared. 6 square root of 2 squared. All right, so that gives me 121.147. So I'm going to, let's see, I thought I would get something different. Just a minute. Oh, I know what I did wrong. Sorry. I was expecting a different number. I know what I did wrong. You're at -9, -5. And I'm just going ahead and doing this just in case you ever need to do it. You wouldn't in calculus. That's your center. You know that it's an ellipse, and another vertex is -9, -16, so there would also be one up that way. The foci is from -9, -5. They only went up and down 6 root 2. So they went -5, up 6 root 2, and down 6 root 2. And so when you subtract these numbers, it tells you how far to count from your center, which was already at -5. And so it went up and down 6 root 2. All right, so to find the foci, you subtract these two numbers. So this number minus our missing number should be how far we counted. So I have 121 minus a squared. This would be 72 when you're finished with it. So you get a squared is 121 minus 72. And what is that? Is that 49? Yeah, so that's 49. Okay, but that's a little more than I would ask you to do. All right, on 16, we have a center at 7, 3. We have a vertex at 7, 9. Let's see, 4, 5, 6, 7, 8, 9. And so we have a focus at 7, -2. So let's go with this. If we have a center at 7, 3, and we have something up here at 7, 9, we also have something 6 units down here. Another vertex 6 units down would be at 7, -3. They tell me they have a foci at 7, -2, so one of your foci is at 7, -2. That makes this an ellipse. If your foci are inside your figure, then it's drawing it toward, and you have an ellipse. So to start the ellipse, I would say x minus 7 squared, y minus 3 squared equals 1. We know we counted up and down 6 because I knew this much. So that would be a 36 under y for up and down. And then you could use this focus distance to find this number. I've already done it, so let's do it again. We know that the focus went from 3 to -2. And so that gives me down 5 units. And so for some reason, to get the focus, somebody counted up 5 and down 5. What would have made them do that is they would have subtracted these two numbers and gotten 5 squared. So I get 9 is equal to a squared, or is that 11? 36 minus 25. So you knew that this one would be 11. Again, that's a bit more than you would need to have in calculus, but there it is. It makes me feel a little better to do it. All right, so this next one, we're not going to deal with the asymptotes and the foci, but that would have to be a hyperbola. Number 18, just to talk about 18, your focus and your directrix. That means automatically you have a parabola. Your two choices are an x equals or a y equals. X equals go sideways, y equals go up and down. Let's go to our focus and think about it. 12, 8. would be way out here. It'd be out here somewhere, 12, 8. My directrix is x equals -2. Just to talk about it a bit, your vertex is right in between these two, and it would be going towards your focus. So it must be an x equal y minus k squared plus h. You can actually find exactly where this is. I may not have drawn it correctly by finding out what's right in the middle from -2 to 12. And so the distance from -2 to 12 is 14 divided by 2 is 7 units away from your focus. And so I actually know my vertex. If I go 7 units away from my focus of 12, I'm at 5, 8. Or if I go 7 units from -2, I'm also at 5, 8, which I don't know if I quite hit here, but that's what would happen. So it would actually be x equals a times y minus, with your y, follow your variable, 8 squared plus 5. And then in calculus, there's ways in algebra to find this a. In calculus, they would give you another point, and you would fill it in for x and y. On the answer sheet, it says it's 1/28, I think, but you're not responsible for finding it. All right, number 19. Let's see. Why don't you do number 19? It's an ellipse, so you'll be working with x minus h squared over something, y minus k squared over something. See if you can figure this one out, and you can check your answer. And you don't have to do number 20. And these application problems are really cool. But you don't really have to do them, but it explains what we talked about in class today. These you will see in calculus, and this is how you would see it. This is one reason I went over it. X squared plus y squared equals 34 is a circle with a radius of the square root of 34. You would never really want to draw a graph without units, but I'm just talking. 3x minus 3y equals 6 would be a line, and we would need to either do calc intersect or in fact, we may talk about that in class one day. You can't even type these into your calculator unless you solve for y with a plus or minus. So you might want to use substitution. I really don't know what this looks like. I mean, it could be the line doesn't even intersect it. It could be the line is tangent to it, or it could cross it twice. I hadn't even really thought much what direction the line's going in, actually. Well, let's graph it. All right, so the square root of 34 is in between 5 and 6, closer to 6. So the radius is right here. And this is a line, -3y equals -3x plus 6. So y divided by -3 is equal to x minus 2. Up 1 over 1. So we have something that looks like this, and you can find these 2 points of intersection. If you were doing it on your calculator, what you'd have to do is solve for y. Y squared is 34 minus x squared, square root. You get plus or minus. So in y1, you could put the square root of 34 minus x squared. In y2, you could put the negative of 34 minus x squared. And in y3, you could put x minus 2. And this would give you this picture. This would give you this picture. And this would give you the line. And then you'd have to make sure you did calc intersect with this one and then with that one. And then here you have a circle, you have an ellipse and a hyperbola. So lots of things can happen with an ellipse and a hyperbola, or an ellipse and a hyperbola. There's a lot of intersecting points, but you don't have to do, could be none, could be 4 at the most, but you are not responsible for that one right now. But next year you would need to be able to understand that to do problems like that and find area. And then in the next video, I'll actually be changing them